Hello everyone, welcome to my channel Code Possibility. In this video, we will see how to use Terraform to create an AWS Lambda function and configure an AWS S3 trigger. The use case we will build is to generate a thumbnail image whenever an image is uploaded to S3 bucket. We will first write a Lambda function which will open the original image from a source bucket, create a thumbnail and store it in another bucket. Then we will configure an S3 trigger to trigger this Lambda function whenever an image is uploaded to the S3 bucket. The prerequisite for this tutorial is to have Terraform and AWS CLI configured. I have already configured my CLI in a profile named Arun Daj, which I will be activating. My profile is now active. I will create a new directory for the project. I will call it as thumbnail generation lambda. We will open this project in the Visual Studio Code. We'll create a lambda function, which I will put it in a directory called src. We will start writing the code. First, we need to define a lambda handler, which will be the entry point for the lambda function, which takes two parameters, event and context. I will import the logging library and configure the logger. As we begin, we will print the event and the context. Next, we need to extract the bucket name and the key from the event. Whenever this lambda function is called from an S3 trigger, the trigger will pass the event object with the bucket and the key, which is the file name, being uploaded. We need to extract the bucket name and key. The first item in this record. Of S3 bucket name. This will be the bucket name, and the key name, which is the image file name, is key. Object key. This will be the key name. Then we will define the destination bucket name and the key. We will call this bucket name as cp thumbnail image bucket. And the destination file name, we will just append underscore thumbnail to the original file name, for which I need to use os.pathsplit. For that, I will import os.path.split extension, and I will pass the key, which will return me the name and extension separately. Thumbnail, name, thumbnail, extension. From this, I will build the thumbnail key, which would be thumbnail name underscore thumbnail and the extension. This will be the destination key. Next, we will get access to S3, for which I need to use the Boto library. S3 underscore client equal to Boto3 dot client S3. Next, I will open the file S3 underscore client dot get object. Bucket name is the bucket, and the key is the key object. I will extract the body of this and read it as a byte string. File byte string. We will load this image in memory bytes IO. For that, we will import byte IO library. From IO, import bytes IO. Then load the image in memory. This will load the image in memory, and then we will use pillow image object from PIL import image. Here you will see some warnings because I don't have this library installed locally, which is not required. We only require it to run in Lambda, which I will show how to configure them. And we will pass this bytes IO image.open and passing this bytes IO and passing this image. Just for the information purpose, we will log the size of this image before we actually compress. Then we will generate the thumbnail. To generate thumbnail, this is the method img.thumbnail, and mention the preferred size. Here I will mention 500, 500 with image anti-alias option passed. The image would have been now compressed. We will again log the size now to see what is the final results size after compression. And now we need to dump this image into a destination bucket. For that, we need to write the image in a buffer and then pass this buffer directly to the destination bucket. Buffer equal to bytes IO. We create a new buffer object and then save the image to this buffer in the preferred format. Now I will be dumping it into the destination bucket. bucket equal to thumbnail bucket, comma key equal to thumbnail key, and then body is buffer. We'll use this send data to validate whether the upload is successful or not. If this response status code is not equal to 200, which is success, we will raise exception. And then finishing the Lambda function by return success. Here in this case, I'm just returning the original event object. With this, we have finished writing the Lambda function. We will then move on to configure Terraform. I will create a new file, main.terraform. We'll first declare the Terraform providers. Here, in our case, we require AWS provider, which we specify here. And then we also require an archive provider, which is required for bundling the source into a zip file and then upload it to the Lambda. And the required Terraform version. With this, we have initialized the Terraform. We will create another file called variables where we put all the variables if required. And then another file output .terraform. In this file, we will configure what are all the variables which we need to print out from the Terraform execution. We'll go to the variables and then define a variable for AWS region, which we are going to use. Name this variable name as AWS underscore region, which is of type string, and the default value is US East 1, which is North Virginia region. Come back to main.terraform file and then configure the provider AWS with the region name var.aws region. With this, we have initialized the Terraform with required parameters. Now we will get started with the actual configuration of our Lambda, and then triggers. First, we need to configure the AWS IAM policies. We will be requiring to create a thumbnail policy, which will grant access to the source bucket to get object and write access to the destination bucket, which I will be configuring now. Resource AWS underscore IAM policy, and I will name it as thumbnail underscore S3 underscore policy. Name equal to thumbnail. And then we will define the actual policy. Here I will be using JSON encode to actually define the JSON. I will be just copying the JSON here. If you see, I have configured allow access to get object action on the resource CPU original image bucket, which is where I will be uploading the original high resolution image. And then I've configured allow access to put object on the resource AWS thumbnail image bucket, which is where I will be dumping the thumbnail image after we create thumbnail from the original high resolution image. Then we need to create the IAM role, AWS IAM underscore role. I will name it as thumbnail lambda role. And then initialize the assume role policy to JSON encode. I'm copying the actual JSON object. This will be the assume role policy. Then we need to attach this IAM policy to the role. Along with this defined policy, we also need to attach the service role, which is for executing the Lambda function, which is AWS Lambda basic execution role, which I will be doing it now. AWS IAM policy attachment thumbnail role S3 policy attachment to which roles we need to attach this policy is to be mentioned here. Here in my case, we have just one role, thumbnail lambda role dot name, and the policy ARN, which we can fetch it from the thumbnail policy resource. Then we will attach the AWS Lambda basic execution role. Nail role for Lambda. For which role? Yes, I am role dot thumbnail lambda role dot name, and the policy ARN. This is a standard policy ARN, which I'm copying here. With this, we have created all the required IAM policy and role for executing our Lambda function. We'll go back to the command prompt. Here, we first need to initialize the Terraform. By running Terraform init, what we actually doing is like the Terraform will download and install all the required packages as we configured in the providers. The Terraform has been successfully initialized. We will now run Terraform. plan. What this command does is, before actually running this or deploying this resources which we have defined in main.tf, it will show us the plan, what it is going to do. Here, the plan is to add 4 resources as defined in the main.terraform file, and there are no changes to the existing and no changes to destroy, because this is the first time we are running. After we review this Terraform plan, we need to apply this Terraform apply. By running this Terraform apply command, we are actually creating these resources in the AWS. We need to type S to proceed. Now the execution is completed successfully without any issues. We can now check the policy, whether the policy has been added or not. I will be using AWS CLI commands for that. List policies, query policies, where policy name is equal to thumbnail S3 policy. You can see the policy is printed, which means the policy has been successfully created in AWS. We will now proceed for creating the Lambda resources. We'll come back to the main.terraform file. Before we create the AWS Lambda resources, we need to create the data resource, which will be the archive of the source code. For that, we will use data attribute archive file thumbnail lambda source archive. And the type we are going to use is zip. The source directory is path.module/src, and then the output path will be path.module/my-deployment.zip. So this data archive file will create a zip file named my-deployment.zip, which will be using in the Lambda resource to upload into the Lambda function. Now we will create with the resource for AWS Lambda function. Lambda function, we will name it as thumbnail lambda. The function name is to be thumbnail generation lambda. And the file name of the source is my deployment.zip file. Next, we need to configure this lambda. We are going to use Python 3.9 runtime, and we need to define the handler, which is the entry point. And then we also have to explicitly mention the memory size, because by default the memory allotted to the lambda will be 128 MB. However, as we are using the pillow library, which consumes or requires enough memory, we are explicitly increasing it to 256 MB. And then now we will configure the source code hash. Base64 SHA 256. and then we'll define the role which we have initialized earlier. Yes, IAM role dot ARN. And then the next thing we need to do is in our Lambda, we are using the library Pillow, which has to be bundled along with the source code. There are two options now. We can either install the Pillow library locally, bundle the app.py file along with the Pillow library as a single zip and upload it, or we can create separate layers for the libraries required. Here we'll take the second approach by creating layer for the Pillow library, and that too we will not be configuring our own library. Instead, we'll be using a publicly available library. In this case, I'm using the Pillow library from K layers. By defining these layers, what we are doing is actually we are importing the Pillow library from this layer, which is a publicly available layer. We have now defined the required resources for the Lambda function. We will now add output variable so that we can print the output of the function name in the console. Output the function name. Value being AWS Lambda function thumbnail lambda dot function name. We will also output the IAM policy which was created. Okay, we will now go back to the command prompt. As you can see, there is only one addition, which is the new Lambda resource, and there is no change to the existing plan, and there is no resources being destroyed. After we review this plan, we will apply the plan. Yeah, the command is completed successfully without any issues. And also you can see the outputs getting printed here, the name of the function which has been created, and the name of the policy which ARN of the policy which was created. Now we will check whether the Lambda is created successfully by running the Lambda AWS CLI command. As you can see the print, which means the Lambda has been created successfully without any issues. Now we'll proceed further for creating the S3 resources. We'll create a resource for the source bucket, AWS S3 bucket, and I will name it as thumbnail original image bucket. The bucket name to be cp-original image bucket. And then we'll create the destination resource. This is going to be just thumbnail image bucket, and then cp thumbnail dash image dash bucket. We will now have to add the Lambda permission to the original image bucket so that the permission is given to that object to trigger the Lambda function. For that, we need to add AWS Lambda permission thumbnail allow bucket allow execution from S3 bucket action to be lambda invoke function name is AWS Lambda function thumbnail lambda dot arm principal s3 dot amazon aws.com and the source arm to be the original bucket name AWS S3 thumbnail original image bucket dot arm. With this resource, we have configured permission to the original bucket to invoke Lambda function whenever there is a trigger. Now we need to configure the trigger, which I will call it as AWS S3 bucket notification. I name it as thumbnail notification. Mention the original source bucket. ID. And then we need to configure the Lambda function which has to be triggered. Lambda function ARN is AWS Lambda function thumbnail underscore lambda dot ARN. And the event it has to trigger is on S3 object created. Whenever object is created in this source bucket, the lambda has to be, this means specified lambda has to be triggered, which depends on the policy AWS Lambda permission allow bucket policy. We have now configured all the S3 resources as well as the permission granted to the S3 original image bucket, and then we have configured the trigger for triggering the Lambda function whenever an image has been uploaded or object has been created in the original bucket. We will now go back to the command prompt to plan and apply this. Terraform plan. As you can see in the plan, we are adding 4 new resources and 0 changes and 0 to destroy. After we review this plan, we will apply it. The resource has been successfully created. As you can see, apply complete without any issues. We can check the S3 buckets whether it has been created or not using AWS S3 command. Yeah, our 2 bucket, which is the original image bucket, and the thumbnail image bucket has been created successfully. And the last thing we need to do with Terraform is to create the Cloudwatch resources so that we can see the logs. I will configure a Cloudwatch resource, AWS Cloudwatch. Log group. And name it as thumbnail Cloudwatch. The name of the log group name is AWS / lambda / and the function name AWS lambda function dot thumbnail thumbnail generation lambda dot thumbnail lambda dot function name, and we configure the retention in days to be just 30. We'll go back to the command prompt and then plan and apply. As you can see in the plan, there is only one new resource to be added, which is the Cloudwatch log group. Now we'll apply. Okay, we see an error now. Log group starting with AWS reserved for AWS. Okay, what we can do is like we can just append a slash before. We'll apply now. Yeah, the command has completed successfully, and we can check whether the log group is created using logs AWS CLI. As you can see the output, the log group has been successfully created. We can check if there are any logs printed here. The log is empty now. With this, we have completed the coding part and Terraform configuration part, configuring the resources in AWS. Everything is up and ready now. Now we will run and check the results. For that, we need to upload a new image. First, we will list the original image bucket and the thumbnail image bucket to see if there are any resources available. The bucket is empty, and then we'll list thumbnail, the destination bucket, which is also empty. Now what we will do is we will upload an image, a high resolution image into the original image bucket. For that, I've already downloaded an image in For that, I've already downloaded an image which is in the downloads folder. I'm going to upload it. Here, I'm uploading the high resolution image into the original bucket. Oh, sorry. I need to use the copy command, cp, which will upload the file from local to the bucket. The file has been uploaded successfully. We will check the Cloudwatch to see if there are any logs printed. As you can see, as the image has been uploaded to the original image, an event has been triggered with with this JSON, which is the source of the event, which contains the bucket name, and the key name, and the object key name here. Lambda has been triggered successfully, and we can also see the logs size before compression, which is 2560 into 1600, which after compression reduced to 500 into 330. Now we will verify the AWS. I'm listing down the original image, but to see the original image of size 6,85,720, probably it's bytes, which has, and then we'll list down the thumbnail image bucket, which contains the same image, high resolution image with underscore thumbnail.jpg, which we have appended in our Lambda. And the size is now reduced to 34,426 KB, or sorry, bytes. With this, we have completed our tutorial on creating AWS Lambda function and writing the Terraform code for configuring the AWS resources. And the last thing we need to do is to clean up the resources by applying Terraform destroy. Before we run Terraform destroy, which will try to destroy all objects we created, when it comes to the S3, it may fail because the bucket is not empty. For that, we have to delete the files manually. We will first delete from the original image bucket, remove. We need to pass recursive flag so that if there are multiple files, it gets deleted in one command. And then we will delete the files from the thumbnail image bucket. We have cleaned up the S3 bucket. Now we will run Terraform destroy. Which will clean up all the AWS resources we have created through Terraform. As you can see, the command has been completed successfully, and the destroy command has deleted the 10 resources which has been created. Hope this video has been helpful. Thank you for watching.